one of the other things that we need to be able to work with is algebra and fractions, and algebra in general a lot better. So let's have a look at this. This is a nice simple fractions with a bit of algebra involved. When we're adding fractions, the first thing we need is a common denominator. Now, 3 times 2 is 6. So that common denominator that we're going to use in this case is 6. So here, what do? We times the top and the bottom by 3. So as long as you do the same to both, it doesn't change the fraction. So you get 9x over 6. 2 times 3 is 6. 3x times 3 is 9x. Here, what do we do to the 3 to get the 6? We times by 2. So we've got to times the top and bottom by 2, and we're timesing the whole of that. So we get 2 plus 2x, or 2 plus 2x. Now that they're all both over the same, they're both over 6, then it's nice and easy. We just add the tops. 2 plus 11x over 6. And we're going to leave it there. But that's a nice way to start at least. Now, it becomes a bit harder if there is algebra on the bottom, because this is a lot harder to deal with. But just as up top, 2 times 3 equals 6. We're going to do exactly the same thing here. X times x plus 2, that's going to be our common denominator on the bottom. X multiplied by x plus 2. So what do we have to do to this? We multiply it by the x over x. So we get 6x. What do we have to do to the x to get to this? We multiply it by the x plus 2. So we multiply it by x plus 2 over x plus 2. 3 times this gives us 3x plus 6. 3x plus 6. And then we just collect like terms again. 6x plus 3x is 9x plus 6 over, and we probably just leave that bottom term like that. Now, this was one of the questions from the homework sheet, and I thought I just might go through this because this is very, very technical. So let's have a look at this. Let's write it out first. Let's write it out as x squared plus 1 over x. That's what this is. And we're dividing all of that by x minus 1 over x squared. Now that looks very complicated, but it mainly looks complicated because we have fractions within fractions. And this is an x squared, this is an x. So what I'm going to do, I'm going to multiply the top by x squared, and I'm going to multiply the whole of the bottom by x squared. So I'm multiplying the top and bottom by the same thing. So what do we get here? We get x squared times x gives us x to the power of 4 plus 1x over x squared. Well, that is just going to be x. If you look over here, we've got 1 over x times x squared. One of those can cancel with one of those just to leave an x. 1 times x is x. When we do it on the bottom, a similar sort of thing happens. X times x squared times x gives us x cubed. And 1 over x times x squared, well, those two things are just going to cancel to give minus 1. And there we go. We could take x out. I didn't see this before, but we could take x out and get x cubed plus 1 up the top, taking an x out, over x cubed minus 1. Now, these look the same and look like we could do something with them, but we can't. These aren't, they need to be exactly the same, otherwise we can't factorise or cancel out. So that is as good as it gets, or as simple as it gets, or this answer is pretty much the same. So let's look at the last one, and this sort of combines a little bit of factorising as well. We've got 3 over x squared minus 4 minus x plus 1 over x plus 2. And this minus is going to be a bit of an issue as well. So a common factor first. Now, those of us that are mathematicians see this straight away as a difference of two squares, and we can factorise it. But if you don't see that, how do you factorise it? Let's look at x squared minus 4. We want to factorise that. So we want two numbers that multiply together to give the back term. So multiply together to give 4 and add together to give, well, there's no x term, so they're adding together to give 0. So they're multiplying together to give 4 and they add together to give 0. So the only numbers that add together to give 0 are inverses of each other. And if they multiply together to give 4, that's going to be x plus 2 and x minus 2. That might be a nice way of thinking of difference of two squares. So this first bracket, if we write it out again, just becomes 3 over x plus 2, x minus 2. And we're going to minus x plus 1 over x plus 2. Now, why do we do that? Let's look at the common denominator. We could just multiply both of these together, but you've got an x plus 2 both of the times here. So all we really need to do is multiply this by x minus 2 over x minus 2. Okay, so what we're going to end up with is 3 minus x plus 1 times x minus 2. And that's going to be over our common denominator of x plus 2, x plus 2, x minus 2. And this is over x plus 2, x minus 2. Okay. Now, if we expand this bracket, this x plus 1 times x minus 2, what we're going to get is x plus 1 multiplied by x minus 2. We're going to get the x squared minus 2x plus x minus 2, or x squared minus x minus 2, which looks pretty nice. So what we're going to get is 3 minus this. All over our x plus 2, x minus 2. And this is where that minus sign becomes a bit nasty, because it's minus all of this, and lots of students always forget that. So I'm sure Alan will slip that into a test somewhere probably. 3 minus x squared plus x plus 2, because this minus affects everything in the bracket, over our common denominator of x plus 2, x minus 2. And then again, you just collect in like terms. So that's 5 plus x minus x squared all over the x plus 2, x minus 2. So that's just mucking around with some of those algebraic fractions that Alan has done. Hopefully that has helped you with this. Thank you.